Good morning, ladies and gentlemen. This is section 7.7 and 7.8 of Mrs. Quinn's geometry class. So today we're going to talk about some properties. Let's start with the properties of a parallelogram. In any parallelogram, the opposite sides are congruent. That means that these sides are equal and these sides are equal. The opposite angles are congruent. That means that these angles are equal and these angles are equal. And the diagonals intersect at the midpoint, which means if this is my midpoint, these two segments are congruent and these two segments are congruent. All right, go ahead and write that down. And the next property we're going to look at is the distance between any two parallel lines is constant. And that makes sense because if this one gets any closer, eventually they're going to intersect. So this distance here must equal this distance here. All right? Parallelogram symmetry theorem. Every parallelogram is twofold rotational symmetry about the intersection of the diagonals. So if this is the center of my rotation, I can rotate twice. Hopefully you would agree I can rotate once 180 degrees. And then I can rotate a full 360 and I'm back to where I began. Twofold rotational symmetry. A sufficient condition for a parallelogram, if it's a quadrilateral, are that one pair of sides is both parallel and congruent. So that means I would need one of these parallel sides to be both parallel and congruent. Or I could know this side. If I know either the blue piece or the red piece, I can say it's a parallelogram. Or I could know both pairs of opposite sides are congruent. If I know both of these pieces, then I can say it's a parallelogram. If I know the diagonals bisect each other. To bisect something means to chop it in half, agreed? So if they bisect each other, if they intersect at midpoints, I can again say it's a parallelogram. If I know that both pairs of opposite angles are congruent, I can say it's a parallelogram. And that's the last one here. Go ahead and write all those down. And a lot of times on tests and quizzes, I'll give you some data and you'll have to say, hey, I can say it's a parallelogram, or no, I can't. So I would actually add these statements along with their pictures to your theorem definition postulate page. All right, for tomorrow, attempt this proof right here. You're given that ABCD is a parallelogram, and I want you to show that this triangle equals, or is congruent to, this triangle. Think about which angles you know are congruent. Think about the fact that they intersect at midpoints. Think about the fact that if it's a parallelogram, these sides are congruent and these sides are congruent. You know so much data. Come back here, take these congruency markings, draw them in on your proof, and then this should only be a couple step proof. And I will see you